Okay, so we are working on your review. This is the I review for confidence intervals, and this is problem 1. Excuse me. A lab tests diesel to make sure that sulfur levels are low enough to be in compliance. On one day, 150 samples were tested and 130 are in compliance. Let P represent the proportion of samples in compliance. So one thing you definitely want to do is, and actually let me open up another tab here. I'm just going to open up a Jamboard, and we're just doing a new one. And I'm going to write down some of the formulas on this Jamboard that might be handy for us when we are working on this. So this is high school stats. IXEO Jamboard, and I'll share it with you guys. I review, call it the review. So this is probably the things you want to write down on your cheat sheet. All right, so we got that. Okay, so one of the things we need to remember is that P hat, and let me see if I can, I'm going to actually expand this a little bit so I can write better. P hat, and I'll just start typing it first, because, where's typing? Here we go. P hat, and I'll do the hat in a second, equals x divided by n. Okay, so, and basically what we're saying here, that's P hat. It's a proportion, and it's the number of successes divided by, actually, I wonder if I can go back in. Where P is the proportion, X are the successes, number of successes, and N is the total number of attempts. So in this case, let me go ahead and spread that out. That's 1. Almost had it. Okay, and it's the total number of attempts. So if we look at our question, we have 150 attempts, and we have 130 successes, so I just go 130 divided by 150. And you should always get a number less than 1. If you get a number higher than 1, then that's a problem. So I'm going to round this to 0.867. You have the tens, the hundreds, and the thousands place, okay? And then calculate the standard deviation for P. So we're definitely going to need a formula. This is the other formula you'll want. So I'm going to go ahead and try and handwrite it. Sigma of P hat, you need this, equals square root of P hat times 1 minus P hat all over your sample size n. So what does that look like in the calculator? Well, kind of jam this sideways. And we have 100 and, so our P hat is, on the calculator, it's 0.8667. So I'm going to go square root second, and then x squared there. See how I have the square root. And I'm just going to take 0.867 times, I don't really need the times, but it's nice, 1 minus 0.867. And then divide that whole thing by the sample size, which in this case was 150. It's not the number of successes that go on the bottom, it's the sample size. So enter, and I get 0.02, 7, and we're rounding to the thousand, 0.028. So let's go see, how's this checking out? Submit for testing. And yay, we've got them right. So the confidence interval, this is another thing we want on our cheat sheet. All right, so I'll just type this one because I'm pretty sure I can do that. Our confidence interval is your P hat plus or minus critical value. Let me put this in parentheses. critical value times standard deviation, or really standard error. Standard error. It's standard error. What's the difference between the two? That's a good question. I'm glad you asked. Basically, it is a standard deviation for a sample. That's all it is. So that's another formula that you want. So if it's written in this format, we can look and take a, let's go ahead and take a look at our sample. We know that it's 0.867, so it's this one, or that one. Then the question is, what is the critical value? Let's see, we're trying to do a 95% confidence level. So what you want to do is you want to go to the stafflet, and we're going to go to normal distributions. Now, by the way, there's another way to do this, which I want to recommend. You do the mean and is 0, and the standard deviation is 1. You remember doing that? And I want the middle 95% of the area. So I'm going to calculate a value corresponding to the area. I'm giving it the area, which is 0.95. And I want it central, because I don't want to be on the low end of the estimate, and I don't want to be on the high end. I want to be in the middle, so I want to be centered around that. So you can see I have 1.96 is my value. So you can see, oh, it's that one right there. That's the correct answer. So we have 0.867 plus or minus 1.96 times 0.028. So you see the number there. You see that number is in the front, and it all works out. Okay, last piece. So if you're trying to find, let's go back to our, where am I? There we go. If you're trying to go back to the formula, there it is, p hat plus or minus critical value. So this is for a proportion, all right? This is not for means. Okay, let's see. Oh, another thing you might want to write down to memorize is the fact that there's some standard critical values. So 95% means that z, which is our critical value, by the way, equals 1.96. Let me just kind of, if it's a 99% interval, I'll show you what that looks like. That means C star is, and it's always the same, because the beautiful thing about the normal distribution is that it doesn't change. So if I want 99% of the area, 0.99, calculate my value, it's 2.58. 2.58. Sometimes we might say or 2.576. So you might see it go out that far. And then we don't do 100%. We also do 90% a lot. So that means C star is, we go back, if we do 90%, 0.90, calculate, you see it's 1.6449. We frequently use 1.645 for this one. And you could round it up if you did or 1.64. Now you're probably going, why isn't it 1.65? Well, if you look at the number, if I'm just rounding based this digit based on the 4, it's actually going to stay a 4. But if I round this digit based on the 9, it goes up to a 5. So that's why it looks funny when you round it. So this might be something that you want to just make sure you have on your sheet. Let me go ahead and I'll call these the critical values. These are very common critical values. There we go. Common critical values. All right, so make sure you know those. And these are for proportions, all right? For averages, because we use the student's t-distribution, it doesn't quite work that way. But luckily, most of the time, we're working with a list of data. All right, so let's see. Margin of error. What is margin of error? So there were a couple of formulas to calculate margin of error. So, oops, not that. We're doing a text box. So, different ways. Find margin of error. ME. So, you could, one of the most common ways to do it is to just multiply out this section right here, the critical value in SE. So way one is you can say margin of error equals critical value and that's probably how we'll do it today, times SE. That's it. Or if I give you an upper and a lower limit, which is not the case here, it is the width of your window, upper limit minus lower limit, and then make sure you subtract it and then divide by 2. So that's another common method. You can also say margin of error is your X bar, your midpoint, your point estimate really, minus your lower limit. So if I was drawing it, I have a nice picture. Let me see. Give me a second. I got to pull it up. Ignore my file coming up here. I'm going to try and pull it off on the side. So, oh, I don't have it on here. We're going to pause for a sec. Okay, so I found the slide that we had when we talked about this before our quiz. This is, excuse me, a nice diagram of a confidence interval. And basically the idea is that your X bar, or it works for P hat too. It's just about the ideas of margin of error. The X bar is in the middle and it's your mean or your P hat. And then you have the margin of error to lower to find your lower limit, and your higher add it to your mean to find your upper limit. So this mean should be right in the middle, smack dab between these two. So another thing that might be handy to learn or to write on your notes, if it's really more for X bar, or it works for P hat too. If you need to find this and you know the interval, you just add these up and divide by 2. But we're not doing that right now. So let's go ahead and calculate. I'm going to use this formula right here, critical value times SC, to figure out our margin of error. It's just basically this piece here. Let me go to my calculator. 0.02, our critical value is 1.96 times 0.028. And I get 0.05488, which rounds to that. So we'll go ahead and test our answer here. And voila, they're right. Yay, go figure. Okay, when alpha equals 0.01, what are the boundaries for a two-tailed critical region with a sample of n equals 20 subjects? So if alpha is 0.01, then that means our, let me go ahead and do this. This is for a t distribution. So I'm going to start another slide for t distributions. So let's call our slide student t distributions. All right. And one thing when you run into a question like this is we need to remember that alpha, or a confidence level, which is CL, equals 100% minus alpha in percent. All right. So in this case, I'm going to just do the work here. Review example. Alpha equals 0.01, which is basically 1%. So CL equals 99%. We want 99% of the area. Okay. Now, the other thing we have to know with student t distributions is degrees of freedom. Degrees of freedom equals n minus 1, where df is degrees of freedom and n is sample size. All right, and they tell you what it is over there. In our example, we have n equals 20, so df equals 20 minus 1, which is 19. All right, so why do I need those? Well, if I'm trying to find a critical value of t, we're going to go ahead and I'm going to go to Stafflet again. Oops. Inverse t. Oh, where is it? T distributions. I'm sorry, I'm thinking calculator speed. And I'm trying to find a value because I'm trying to find, see, this is a value. This is not an area. How do I know? It's bigger than 1 for part of it. Degrees of freedom, I'm going to put 19 in. Do not put 20. You'll be slightly off. And if you wanted to, you could plot the normal distribution, but we're not going to worry about that. and we want to calculate a value, not an area. We know our area is going to be in the center. Actually, I'll go ahead. What is this? We said 99%, 0.99. If I do it left tail, that means my confidence interval is not centered about this mean, so it's very important to have it centered. Hit calculate, and I'm getting negative 2.8609. Oh, and that's another example. If you had done left like that, see how you only get the one value because it's marking off the low and the high? But we're doing a confidence interval, and you can see how all the answers say plus or minus. That tells you for sure you want to do central. And it's 2.861 is the answer I'm getting. And we'll go check that. Amazing. I got it right. Go figure. Okay, which of the following is true as sample size increases? So basically, remember we did this in the review for the quiz. So this question's here on the review. Could it be on the test? Maybe. What of the following? I should say which of the following. And that's a textbook question. That's funny. The t distribution becomes more like a normal distribution. This is true. The critical values of t become smaller. Well, let's try it. We'll just do it with this one. Let me put, we'll start with the small sample size. We'll say 2, right? And our critical value, so this is our starting point. Ooh, it's 9. Look at that. That's huge. All right, let me go ahead and put 4 in. Now it's down to 4.6. Let's put in 10. Now it's down to 3. And I could just keep clicking. And what do you notice about the values here as I increase the sample size? They are going down until they eventually get very close to the normal distribution, which is, oh, I didn't mean to do that, which is this distribution. So you can see it looks almost the same. Those little red, you can barely see them dots right there. Okay, so the critical values of t do become smaller. We just tested that. All of the other options are true. Well, let's check this one. The value of degrees of freedom increases. Well, yeah. Why does it increase? Well, because we said degrees of freedom is n minus 1. So the bigger your n, the bigger the df. So all of our other options are true on this one. Okay. Now, suppose you were told that a 95% confidence interval for the average price of a gallon of regular gasoline in your state is from $3.40 to $3.69. Actually, this is really on my other slide. I'm going to steal this. I'm going to put it on this slide too. All right. So in our case, the two levels are $3.40. So let me show you what that looks like here. So that means this is $3.40 and this is $3.69. Let me go put another text box in, right? Well, they ask you, what is X bar? X bar is the middle. So in this case, X bar will be the average. So the formula is X bar equals your upper limit plus your lower limit, or you can go in the other order if you want. Lower limit plus upper limit divided by 2. Okay. So if we calculate it in this case, it would be X bar equals 340 plus 369 divided by 2, whatever that equals, and that's where we grab our handy dandy calculator. So our handy dandy calculator, I'm going to take those two and add them. So it's 340 plus 369. Now if you do this like this, if you hit divide by 2 here, it's just going to divide the second number, so don't do that. So it might be better to go ahead and use parentheses just to make sure that you are getting the right answer. That's not what I wanted. Let's try that again. Parentheses, 340 plus 369, parentheses, divided by 2. I get 3.545. Now, notice how we have red numbers on this. What does that mean? Your problem is probably going to be different than mine. Let's go ahead and make sure we have that one right before we continue, because I'm going to need that number to calculate the other. So why miss this when we can just first make sure we're using the right number? Okay, now the error is also known as the margin of error. It's this thing right here. Well, I know that this is 3.545. So I could put this number right here. Text box. And if I wanted to find ME, what I could do, or E, it's called both, is I could just basically subtract these two. That would work. So ME, remember we said could be the X bar minus the lower limit, whatever that turns out to be, which is what we'll do here. I could have also done the upper limit minus the X bar. Make sure that your margin of error is always positive. In this case, it's 3.545 minus 3.4. And then let's just get the calculator to do that. 3.545 minus 3.40. And I get 0.145, 0.145. Okay, very nice. And, oh, I guess I should make sure I'm right. Yeah. Never know. Could have had a brain spasm. It happens. I got them both right. Go figure. Okay. Now, these, you should be having a tiny little celebration when you see this. So we have the Wind Mountain Archaeological Site. It's located in southwestern New Mexico. Wind Mountain was home to an ancient culture of prehistoric Native Americans called Anasazi. Very mysterious group. A random sample of excavations at Wind Mountain gave the following depths in centimeters from present-day surface grade to the location of significant archaeological artifacts. So they want us to calculate the average and the standard deviation. So we're going to go to another staplet. And we're dealing with a quantitative variable, which is depth. It's just one. And we're only dealing with one sample of data. So the nice part is you just take this, hopefully. Let's see if they all go in. And I'm going to paste it. Voila. Oh, isn't that beautiful? I could say depth in centimeters if I wanted to be extra nice. And this is what my data looks like. Well, my X bar is the mean, so I just copy that over, 74.2. And my standard deviation is this SD thing, 18.253. I wonder if it's going to ding me for that. We'll see, because I'm going more decimal places than it says. So always, when you get these two-parters, always check the first part before you continue on. Because you could also, if you type the data in, you might have typed in a number incorrectly. So you can see these are fine. And even though it said only one decimal place, it accepted that. Compute a 99% confidence interval for the mean depth mu at which archaeological artifacts from Wind Mountain's excavation can be found. So we come down here to perform inference. So let's make a note. Let me see if I can move this. I'll just, to create a confidence interval. Confidence interval. From data, use the one quantitative variable statlet. Quantitative variable statlet. Enter data and go down to perform inference. I'm trying to see if I can fit this all up here. All right. Yeah. All right. So we're going to go down on this here. Let me just move this over here so you can see what I'm talking about. So we already have our data here. And then use one sample t interval for mu. Use one sample t interval for mu. I'd have to type it this way. I guess I could hand draw it. All right. Make sure the confidence level is set right. And right now it defaults to 95%. Defaults to 95%. All right. So let's see, which confidence level we're supposed to use? It's 99. So see, if I had left that at 95, I would get the wrong answer. Let's change this to 99. Perform inference. And there's my interval. That's my lower limit and my upper limit. Now, some kiddos will like, well, the lower's on top, so I should put they try to put the upper on top. No, no, no. It's always the first number, then the second number. 60.1704. I'm going to try and put a lot of decimals, see if it's okay with that. 88.2296. And again, let's see. Calculate, submit for testing. Let's see how we did. And there you go. Even though it said round your answers to 1 decimal place, usually WebAssign is very happy to accept more precise answers. Okay, so we're going to do the same thing again. We have another set of data. So this problem number 6 is pretty much identical to the problem 5. Now, you may have a different confidence level than me. So I'm going to call this one is rim diameter. So I'm just going to replace rim diameters. Also in centimeters, all right, and edit inputs, Control Alt, Control V. I have pasted in all the data, 13.4, yeah, all that's in there, 15.9. Begin analysis, and let's go ahead. My mean is 15.78. My standard deviation is 3.4608, which is the typical distance between the mean and all these data. Just to remind you. All right, and let's make sure those answers are correct before we go down here, because maybe some of my data pasted incorrectly. And they're fine. So now I can go down here, remember, perform inference, 1 sample t interval for mu, and we're doing 99% again, so I'll hit perform. And remember, the first number goes in the first blank. You're probably going, but wait, that one's the upper one. No, that's not what we mean. We mean upper, like bigger number. All right, so that's what we mean. And let's go ahead and submit for testing. And voila, there they are. Okay, now this one, see how on these we had data and averages and things like that? On this other one, we're talking about proportions. So this is more like the pots we were dealing with. Let me go ahead and put this back in here so I can have it. We're doing a proportion. So that would be this slide here. This is the proportion slide. Okay. They conduct an extensive survey of 3,143 wage and salaried workers. So one thing to remember is N is the total sample size, right? N equals total sample size. X equals successes, and then N minus X equals your failures. All right, in other words, your nots. So let me show you what I mean when I say that. All right, so that's something to keep in mind and remember when you're doing these problems. So what I'm going to do in this case, N is 3143. Let me go pull up the calculator. So we got 3143, and we have 1470 successes. So that means minus 1470. The rest are failures. We have 1673 failures. So I'm going to kind of remember this. And the staplet you want on this one, actually, let me put a link on this staplet on the board. So did I say, oh, I already have it here, right? So this is very important right here. Make sure you know which one it is. That one right there. Can I do it without making any big giant mistakes? Oh, look at that. All right. So for this one, the staplet we want is helpful staplet is one categorical variable. All right. So that's the one we want. So let me go ahead. So for proportions, and this is what we're going to need to go with that. I'm going to move this just a little bit. We don't need it all the way there. So if we're trying to actually calculate a confidence interval, let's go get a staplet. We don't have that one yet. So you see we're on our 4th staplet. So part of the trick is to know which staplet to use. We want categorical variable, just one single group. All right. So the first thing, let's take a look at these numbers. We have the total is 3143, but I'm not going to put the total in here, all right? So the variable is, what does success mean to you? And then we'll say personal satisfaction. And then the frequency is 1470. Now the next one, we can just say not personal satisfaction, which would be the leftovers, which we calculated over here is 1673. So when you begin your analysis, it should have, see how it has the total there, that 3143 should match that. So now we don't need this calculator. Let me go ahead and put it up for just a second. Okay, so they want a confidence interval. That means I have to keep on going down, perform inference, and the method we want is a one sample Z interval. That's what we want. So let me make a note on our thing. Use one sample Z interval in inference section. To create the interval. Note confidence level defaults to 95%. All right, so let me go ahead and just make this much longer. Much longer. That's fine. All right, and move it so you can read it. There we go. All right, so I'm going to go to my Staplet where I put the data in, right? So it's a one sample Z interval. Is that what I wrote? Let's see. A one sample Z interval. Yes. Yeah. So that's pretty much it. And I want it for personal satisfaction. I don't want it for, oh wait, yeah, we're up here. I was looking down here and I'm going, what? And then our confidence level, we want a 90% confidence level. So make sure you change that. Perform inference. And then I just can type these in. 0.4531 and 0.4823. And then let's go ahead and check. We're almost done. You're probably going, this is taking a while, Mrs. Overman. Well, there you go. I'm trying to teach some of you who haven't learned it the first time. All right, and that's it. We have the right answers. Okay, now we have another proportion one. 3-circle, red on white is distinctive pattern painted on ceramic vessels of the Anasazi period. Oh, that sounds familiar. We had 179 total, right? And 62 were the 3-circle. So I can come up here. I'm just going to edit my data. And we have the 3-circle pattern. I'm just going to call it that. I'm not going to type everything. 62 were that. And then not 3-circle. And so I still have to figure out what that is, which means I need a little calculator. And I'm going to take the 179 minus the 62. So these are how many are not that pattern. And I'll put that in there. It's 117. And begin analysis. And come down, we want the point estimate. So the point estimate is actually in here. Technically, I don't have to put it in the calculator. So I could say 62 divided by 179. Let's just do that. So you can see 62 divided by 179. Enter. And I got 0.346, right? Oh, darn. My staplets went away. All right, let me get another one. Give me a second. So sad. All right. Oh, this is my personal kit. It doesn't matter. All right. So this is Staplet. Yeah, I watch stars on here. Staplet.com. All right. So try that again. So sad. So sad. Mrs. Everman, you were almost done, and then you hit that. I know. All right. Okay, one categorical variable, single group. That's the Staplet we want. And this is Potsherds. And then funny pattern, we had 62. And then not funny pattern, I think we had 117. Yeah. Begin analysis. And then I accidentally hit scroll that. And then I come down. So see how this 0.346 is very similar to what we got on the calculator. And oh, but here you probably do want the calculator because they want 4 decimal places. So the problem with using the staplet there is that it only rounds to the 3 decimal places. In fact, if I wanted to, I could skip rounding and just do that. I could do all that. Let's make sure we have the right proportion before we continue. And there you go. See how it accepted it. If you put more decimals, it's always happy. If I had only done 0.35, watch what happens. Doesn't like it. So I'll put that back to 0.3463. That's fine. All right. So my lower limit, I need to do a 95% confidence interval. So I'm going to do a 1 sample Z interval like we mentioned before. And we want 95%. And there's my lower limit, 0.277, 0.416. And let's see how this looks. Oops, it didn't like it rounded. What was my point of it? Oh, I think it's a different number on my calculator. Huh, interesting. Oh, because that's 3 decimal places. Okay, that makes sense. 87151. So now so I don't have to think, I'll just fix it. So we know that's right. Okay. For this problem, carry at least 4 digits after the decimal in your calculations. Good news, since you're using the staplet, it will do that automatically. So I can tell this is another proportion, so we want to be on this one, all right? We have a random sample of 738 women. Well, that's going to be my total down here, so I don't need that right now. So let me edit my inputs. And then we have the loyal women and the not loyal women. So loyal. We have 622 loyal shoppers. Not loyal. Well, how do I find that? I'm going to subtract. It's not this 117. That has nothing to do with anything. I need to go 738 minus 622. And I get 116, so I'll put 116 in here. Begin analysis. Can find my point estimate. Oh, this one says 4 decimal places, so the problem I have here is, not so good. So let's double check. We're trying to do 4. So we had 622 successes divided by 738. And I get 0.8428. Okay. And let's make sure that's the right proportion. And it is. So now we're ready to create a confidence interval. I'm going to do a 1 sample Z interval of loyal. And we want a 95% confidence level. So we perform inference and then I copy. Ooh, okay. Luckily that says 3 decimal places. It's like, wait a second. So now we get to which statement are we going to use? So let me go ahead. Oh, my Jamboard. I need it from the other one. I need my Jamboard. Hold on. I realized I have the wrong. Ignore this that I'm pulling up. There we go. That's my email. Ignore. All right. So because we had our notes on that, right? And I want to make sure we get our notes back. So I'm going to close this out because, and here we go. Bring back my Jamboard. It has our beautiful notes on it. Sure. Okay, so what are we trying to find? How do we interpret? So let me just do one last slide, or actually I might be able to fit, it's a little tight. I'll do one last slide. How do we interpret an interval? So it's pretty much the same whether it's proportions or means. So how to interpret an interval? We are blank % confident. All right. So we should see that. And you see it in all these. So where this is your CL value, let me kind of just, that the true proportion or maybe the true mean falls of whatever context falls within this interval. Okay. Now, how do we know what % goes up here? Well, it's a 95% confidence interval. So we don't want the 5. That's bad. All right. That's not what we want. We don't want that one. So now we are down to 2 choices. So this makes it super easy. We always want it within. We do not want it outside. Okay. And as a news writer, how would you report the survey results regarding the percentage of women supermarket shoppers who remained loyal to the favorite supermarket during the last year? You could repeat it, report the confidence interval. You usually report it this way, p hat, because people like to have an actual value. So let's go ahead and make sure we're good for all that. Most of the time when you see a survey, it is the p hat and plus or minus this. So that's typically how it's reported. What is the margin of error based on a 95% confidence interval? So if we look at this, right, let's go back and look at our pictures. Margin of error is just going to be, there are a couple different ways. Let's see if I have them all here. Yeah, see, I can take that upper limit minus that lower limit divided by 2. So I'm going to take this one minus that one, big one minus small one, subtract and divide by 2. So big one is 0.869. Minus 0.817. Now, since I didn't put parentheses, I better hit enter. Otherwise, it'll just divide that part by 2. And then divide by 2. So my margin of error is 0.026. Let's check that. And voila, it's all good. So now we're to our last data. Right? We want to do a list of data. So automatically, you do a list of data. You don't even have to read the problem. I'm copying the data. I'm going to go to Staplet. And we want the one quantitative variable. So far we've been using that one, t distributions and normal distributions. But we want one quantitative variable, single group, raw data. What are we looking at? % of hospitals providing. Now, this is kind of a weird one because it really means charity care. It's not proportions. It's tempting to think it's proportions, but it's actually, how can you tell? It says X bar in the problem. So if it says X bar, this is the one you want. I'm going to paste the data in here. Begin analysis. And let's make sure my mean and my standard deviation are good, 62.28. And 7.9204. Submit. And we're good up there, and then I can just perform inference. We want a 1 sample t interval. And what confidence level? 90. I want a 90% confidence level to perform inference. And then I can just copy these numbers in, 57.68. 7, you can just basically type the whole thing in without even having to worry about rounding. And voila, that is it. Enjoy. Good luck on your test. Oh, just to refresh, again, you've got, these are the slides that we did, and I will post them to Google Classroom on the review assignment.